Every minute a machine sits idle on the factory floor, your profit margins bleed out into the ether. For decades, B2B manufacturing leaders have accepted this operational hemorrhage as the unavoidable cost of doing business. The staggering capital risk of retooling physical production lines, coupled with the devastating financial impact of unexpected equipment failures, creates an environment where innovation is inherently dangerous. You are forced to gamble millions of dollars on physical prototypes and workflow changes, hoping the math works out when the power is finally switched on. Siemens did not just accept this operational bleeding, they systematically eradicated it. By weaponizing digital twins, they fundamentally altered the physics of industrial production. This is not theoretical modeling or basic 3D rendering. It is the deployment of high-fidelity, AI-powered simulations that mirror physical reality with terrifying precision. They have created a parallel universe where factories run flawlessly in the cloud, allowing them to test, break, and optimize systems without ever touching a physical wrench. To understand how they achieved this dominance, you must examine the underlying architectural strategy. Siemens builds a complete, mathematically perfect virtual replica of a factory before a single piece of steel is ever cut. They feed this construct with relentless, high-velocity streams of industrial IoT data. This creates a living, breathing digital entity that learns continuously from the real-world conditions of its physical counterpart, forming an unbreakable feedback loop of intelligence. The financial impact of this synchronization is immediate and profound. Instead of halting physical production to test a new workflow, engineers stress test tens of thousands of variations in the cloud simultaneously. They eliminate risk entirely from the physical realm. By the time a new process is deployed on the actual shop floor, it has already been proven successful across millions of simulated hours, achieving optimal efficiency without jeopardizing active output. Consider the traditional nightmare of mechanical failure that plagues legacy operators. Unplanned maintenance destroys production schedules, shatters delivery promises, and erodes client trust in the B2B sector. Plant managers traditionally operate in a state of constant reactive panic. They are forced to wait for a critical component to snap, grind, or overheat before scrambling to dispatch repair teams and source replacement parts. The virtual replica flips this dynamic from reactive desperation to aggressively proactive control. Through advanced predictive maintenance algorithms, the AI analyzes microvibrations, temperature fluctuations, and torque variances from real-time sensor data. It identifies the microscopic precursors to catastrophic failures weeks before the human ear could ever detect a grinding gear on the assembly line. This foresight transforms maintenance from a massive sunk cost into a strategic competitive weapon. Siemens schedules highly targeted repairs during planned operational pauses, ensuring unprecedented levels of uptime across their global footprint. The physical machines are pushed to run until the exact mathematical moment of optimal intervention, squeezing the absolute maximum lifecycle value out of every single capital asset on the balance sheet. That shift from reactive scrambling to calculated precision redefines market leadership entirely. When your production lines never unexpectedly stop, your supply chain becomes an impenetrable fortress. You dictate terms to the market because your delivery capabilities are mathematically guaranteed by the simulation. Competitors who still rely on the break-fix model simply cannot compete with a supplier whose downtime approaches zero. Building this capability requires a massive, unyielding data pipeline that most organizations fail to architect properly. You cannot simply buy an off-the-shelf software license and expect a fully functional virtual factory to materialize. Siemens orchestrated a deep, complex integration of hardware sensors, edge computing devices, and cloud-based AI to ensure absolute, latency-free communication between the physical and digital realms. Look closely at their Amberg electronics plant, a facility that produces tens of millions of products annually with a defect rate approaching absolute zero. The digital twin at this facility processes over 50 million pieces of manufacturing data every single day. This relentless, crushing volume of information allows the AI to autonomously adjust manufacturing parameters in real time, optimizing production flows without requiring human hesitation or intervention. The efficiency gains extracted from Amberg prove that operational perfection is highly scalable. By simulating the entire production lifecycle from inception to delivery, Siemens compressed their product development cycles by unimaginable margins. They bring complex, highly customized B2B solutions to market in a fraction of the time it takes their legacy competitors to even prototype a basic concept. Yet, despite this overwhelming evidence, many B2B enterprises still hesitate, paralyzed by the perceived complexity of deep integration. They look at the initial capital expenditure of widespread sensor deployment and cloud data infrastructure, mistakenly classifying it as an IT expense rather than a core survival mandate. This hesitation is a fatal strategic error in a rapidly evolving industrial landscape. The true risk is not the upfront cost of implementation, but the devastating cost of remaining completely blind. Siemens understood that operating without a digital twin in the modern era is akin to flying a commercial airliner through a hurricane without radar. The simulation provides the ultimate risk mitigation framework, illuminating every potential failure point before it can manifest in reality. By moving the costly trial and error phase entirely into the cloud, you insulate your corporate balance sheet from the harsh physics of reality. If a simulated factory retooling fails catastrophically, you lose a few dollars in compute cycles, not millions of dollars in scrapped raw materials and lost labor hours. You buy your engineering teams the freedom to innovate aggressively because failure is suddenly entirely free. To replicate this market dominance, your organization must fundamentally change its relationship with information. You must stop treating data as a passive byproduct of manufacturing and recognize it as the primary raw material of the modern factory. You must aggressively instrument every critical asset, ensuring that every motor, conveyor belt, and robotic arm speaks fluently to your central AI architecture. Once that robust infrastructure is established, the AI transitions from being a passive observer to an active, relentless orchestrator. It begins running continuous Monte Carlo simulations on your global supply chain disruptions. It tests exactly how a sudden raw material shortage in Asia will impact your shop floor in Europe before the supplier even picks up the phone to deliver the bad news. The echoes of those initial data integration hurdles fade the moment you realize this unprecedented level of operational agility. Your executive leadership team is no longer guessing about production capacity or relying on outdated spreadsheet models. You are executing mathematically proven strategies, allowing you to confidently bid on massive enterprise contracts, knowing exactly how your factory will absorb the increased load. This is the brutal, unforgiving new reality of B2B manufacturing. The companies that stubbornly rely on physical prototyping and reactive maintenance schedules will be systematically dismantled by competitors running continuous AI-powered optimizations. The digital twin is no longer a futuristic luxury reserved for global conglomerates. It is the absolute baseline requirement for industrial survival. Siemens is already pushing this boundary even further, seamlessly integrating generative design into their virtual environments. The AI does not just passively monitor the twin to report on current conditions, it actively suggests entirely new factory layouts and robotic pathways. It designs radical new efficiencies and spatial configurations that human engineers bound by traditional thinking would never conceive. This self-optimizing loop creates a compounding competitive advantage that is mathematically impossible to catch once it accelerates. Every single day the physical factory runs, the digital twin gets smarter, the predictive models get sharper, and the profit margins grow wider. It is an accelerating flywheel of profitability that leaves traditional manufacturers permanently trapped in a bygone industrial era. Your mandate as a visionary business leader is remarkably clear and highly urgent. You must demand the immediate virtualization of your core operational assets. Start by identifying your most critical production bottleneck, deploy the necessary sensor networks to capture its behavior, and build a localized simulation to prove the concept and secure immediate, undeniable ROI. The era of blind, reactive manufacturing is definitively over. By aggressively embracing AI and digital twins, you are not merely upgrading a factory, you are engineering an invincible operational machine. You will eliminate downtime, dictate the absolute pace of industry innovation, and secure unshakable market dominance in a landscape where data-driven precision is the ultimate currency.